On an ordinary afternoon, traffic for a huge service stops behaving. Requests that should travel a few hundred miles to a nearby data center suddenly take a detour, looping through a small network on the other side of the world before coming back. Nothing on your screen looks wrong. The page still loads, the app still works, the little lock icon is still there, but for a few minutes, a slice of the internet quietly went somewhere it was never supposed to go. No cable was cut, no server was hacked in the way people imagine hacking. Somebody somewhere simply announced to the rest of the internet that they were the right place to send that traffic, and for a while the internet believed them. This is BGP hijacking, and to understand why it is possible at all, you have to understand that the map the entire internet follows is not enforced. It is agreed to, and an agreement is only as strong as everyone's willingness to tell the truth. The internet has no map. Start with a thing most people never question. When you load a website, your request has to find its way across the planet to a specific machine, and there is no master map of the internet that tells it how to get there. There is no central authority that knows every route and hands out directions. The internet is not one network, it is tens of thousands of separate networks that have agreed to carry each other's traffic. Each of those networks is run by someone different. An internet provider, a university, a cloud company, a government, a bank. Each one controls some block of addresses, the numeric destinations that everything online ultimately resolves to. And the only way your traffic reaches the right block is if all the networks in between have a shared, constantly updated sense of which network can deliver to which addresses. That shared sense is the map, and nobody owns it. This is worth pausing on because it runs against how people imagine the internet. There is no headquarters, no single machine holds the master directions, and no one could, because the map changes thousands of times a second as networks come online, drop offline, and rearrange how they connect. What you think of as one seamless thing is really a loose federation held together not by a central plan, but by every member constantly telling every other member where it can be reached. Networks that announce themselves. So how does that map get built if no one is in charge of it? The networks tell each other. Each network announces out loud which ranges of addresses it can deliver traffic to. It says, in effect, send me anything bound for these destinations and I will get it there. Its neighbors hear that announcement, believe it, and pass it along to their neighbors, who pass it along again. The cheat protocol that carries these announcements is called the Border Gateway Protocol. It is the language networks use to gossip about who can reach what. There is no grand database. The map is just the sum of all these announcements, propagating outward, each network learning the shape of the internet from what the networks next to it are saying. It is less like a printed atlas and more like a rumor that the whole world keeps repeating until it becomes the truth. Built almost entirely on trust. Now the uncomfortable part. For most of the internet's life, those announcements were taken on faith. When a network said it could deliver to a certain block of addresses, its neighbors did not check whether that was actually true. There was no built-in way to verify the claim. You said it, they believed it, and the belief spread. This was not stupidity, it was how a global system got built fast by a relatively small group of operators who mostly knew each other and mostly behaved. Trust scaled when the internet was small, but the design never really changed, even as the internet grew to carry banking, elections, hospitals, and most of human communications. The core routing of the modern world still runs, to a surprising degree, on everyone agreeing to tell the truth about which addresses are theirs. When the announcement is wrong, so picture a network announcing a block of addresses that does not belong to it. Maybe by mistake, a fat-fingered configurations. Maybe on purpose. Its neighbors hear the announcement and have no built-in reason to doubt it. They believe it, and they tell their neighbors, and the false claim ripples outward across the internet. Sananter kaninanter kembanin limitations, their neighborhoods and the family there. Routing tends to prefer whatever looks like the more direct or more specific path, and a carefully crafted false announcement can win. When it wins, traffic that was supposed to go to the real owner gets pulled toward the network that lied. That pull is the hijack. The map has been quietly rewritten, and almost nobody watching their screen will notice. The network that swallowed a giant. The most famous incidents are not movie villains. They are small mistakes that scaled catastrophically. The classic shape is a tiny network in one country accidentally announcing addresses belonging to a giant global service. One operator makes a configuration error, claims a range that is not theirs, and suddenly a significant chunk of the world's traffic for that service tries to funnel through a single small network that was never built to carry it. The result is usually not theft, it is collapse. The service appears to go down across whole regions because the traffic is being dragged into a place that cannot possibly handle it, and it simply drowns. A giant gets knocked partly offline, not by an attack on its own systems, but by a stranger on the far side of the planet, quietly claiming to be it for a few minutes. The internet believed the smaller voice, and a billion-dollar service blinked out. What makes these stories stick is how little it took. No army, no exploit, no clever break-in, one wrong line in one network's configuration, repeated faithfully by every neighbor that heard it, because repeating what your neighbors say is the entire job of the protocol. The system did exactly what it was designed to do. It spread an announcement, the announcement just happened to be false, and the design had no way to know the difference. Traffic that takes the long way, other incidents are quieter and, in some ways, more unsettling. Instead of knocking a service offline, the rerouting just moves the traffic somewhere it should never have gone, and then lets it continue to its real destination as if nothing happened. Data that should have stayed within one region suddenly detours through networks in another country entirely before completing its journey. To the user, everything still works. The page loads, the call connects, the transfer finishes. But for that window, the traffic passed through hands it was never meant to pass through. When a route quietly detours through an unexpected country, anyone sitting on that path is in a position to watch what flows by. The danger is not the delay. The danger is that for those minutes, your traffic had an audience you never agreed to. Dropped, watched, or impersonated, so what can someone actually do with traffic they have pulled toward themselves? Broadly, three things, and they get worse as they go. The first is simply dropping it. The traffic arrives at a place that does not want to deliver it, and it dies there. That is a denial of service. A service goes dark not because it failed, but because its mail was redirected to a black hole. The second is watching it. Traffic that passes through a network it was never meant to touch can be observed in transit. The third, and the most serious, is impersonation. If you can convince the internet that you are the right destination, you can try to stand in for it, answering as if you were the real service. Encryption is the main thing standing between a hijack and that worst case, because even traffic sent to the wrong place is far harder to read or fake convincingly when it is properly protected. But the rerouting itself, the bending of the map, happens underneath all of that. Why it is hard to see? Here is what makes route hijacking so different from the hacking people picture. There is usually nothing broken on your end to notice. Your device did its job perfectly. It asked for a destination and followed the directions the internet gave it. The problem is that the directions themselves were quietly wrong several networks away in a layer you have no window into. The people best placed to catch it are the operators watching the global routing tables, the ones who notice when an announcement appears that should not exist, or when a familiar block of addresses suddenly seems to belong to a stranger. For everyone else, it is invisible by design. You cannot see the map your traffic is following. You can only trust that the networks carrying it are telling each other the truth, teaching the internet to check. So the obvious question, if the whole problem is announcements taken on faith, why not just check them? That is exactly what the defenses now rolling out are trying to do. The first piece is a way for the real owner of a block of addresses to publish a signed statement saying which network is actually allowed to announce it, a signed route origin, cryptographically tied to the rightful holder. The second piece is filtering. Networks increasingly check incoming announcements against those signed records and against sane expectations, and refuse to pass along claims that do not hold up. An announcement that fails the check gets dropped instead of believed. It is the internet slowly learning to ask for identification before it repeats a rumor, after decades of repeating every rumor it heard. Neither piece is magic, and that matters. A signed record only proves who is allowed to announce a block of addresses. It does not, by itself, watch the whole path that traffic takes afterward, which is a harder and still unfinished problem. So the defenses shrink the space for the crudest hijacks, the obvious false claims, without yet closing every clever variation. They raise the cost of lying. They do not make lying impossible. Defenses that are still half-built. It would be neat to end by saying the problem is solved. It is not. These defenses work, but only as far as they have spread, and adoption is uneven across the tens of thousands of networks that make up the internet. Assigned origin only helps if the networks around you actually bother to check it. Filtering only protects the paths where someone took the trouble to filter. So the internet today is in an awkward middle. Parts of the map are now verified, and a false announcement there will be caught and rejected. Other parts still run on the old honor system, where a confident lie still propagates. The trust is being slowly replaced by proof, network by network, but the work is far from finished, and the gaps are exactly where the next quiet rerouting will find room to happen. The map is still a promise, so step back and look at what the internet actually is. Not a fixed structure, but a continuous agreement, rebuilt every moment out of announcements that networks make to each other about what they can reach. It works astonishingly well, billions of times a second, almost always carrying your traffic exactly where it should go. And it does this mostly because the people running those networks choose to tell the truth. That is the unsettling thing to sit with. The map the entire internet follows, the directions every piece of your traffic obeys, is built on everyone agreeing not to lie about which part of the world is theirs. The cricketerfery is catching up. But for now, the most fundamental layer of the system we have wired our entire lives into still runs, to a remarkable degree, on faith. Follow the rabbit hole. If you want more of the internet explained from the inside, the systems most people never see and never think to question, this is the channel for it. No products, no pitch, just the machinery and how it really works underneath. Subscribe and follow the rabbit hole. Next time we go up one layer, to a system you touch every single day and almost never think about, the spam filter. It is the oldest arms race online, a quiet war that has been running since the first junk message ever sent, and it is far stranger and far smarter than the folder it hides behind. That is the next one. Inside the spam filter, the oldest arms race online.